Hello.
Hello, sir.
Hi.
Ready again.
Yes.
Okay. Um, we have to waiting for the student.
Okay.
Good morning, guys. Good morning, Camila, Samuel, Secundo, Arturo. The class going to be the start right now. So the class is yours, sir. Welcome, guys.
Okay.
Enjoy the class, and if you have some question, you can turn your microphone or you can ask directly to the teacher. It's 1 hour, the class, sir.
Mhm. Okay. So today the first thing that we're going to look is triangles. So okay, so a triangle has three sides and three angles. We all know it has three sides, three angles, and the three angles all up to 180. Okay, three angles add up to 180. Okay. Okay, so there is different types of triangles: equilateral, isosceles, and scalene triangle. So okay, so these are the names depending on how many sides on the sides. Like if the three sides and the three angles they are same, then it's an equilateral triangle. It has three equal sides and three equal angles, and angles are always 60 degrees. Okay, isosceles triangle is the one in which two sides and two angles are equal. Like in this side and this angle, they are equal. So it's an isosceles triangle. And then there's a scalene triangle, so it have no equal side and no equal angle. All the angles are different and all the sides are different. Okay, so equilateral means equilateral. Lateral means the sides, so they have the equal sides. And the isosceles means equal legs. We have two legs, so iso has two legs that are equal. Okay, and scalene means uneven or odd, so no side is equal. Okay, so these are the names and types of the triangles. The ones are acute triangles. So if the angles, all the angles, they are less than 90 degrees. If all the three angles they are less than 90 degrees, none of them is more than 90, then it's a acute triangle. And then it's a right triangle if it has a one angle which is 90 degrees. So one angle is 90 degrees, then it's a right triangle. Similarly, obtuse triangle, okay, if it has one side which is more than 90 degrees. So any one of the angle is more than 90 degrees, then it's an obtuse triangle. Okay, so we can have we can have combined names. Like for example, this one is a right isosceles triangle because this side and this side they are equal and it's a right triangle, right? So it's a right triangle. So we can say that this is a right isosceles triangle. Okay, so now there is a question. Can you guess what the equal angles are? What are the equal angles here? How much is this and this? Okay, So obviously this one is 90, right? And the remaining two are equal. This plus this. So basically this plus this is 90 degrees, right? So they are 90 degrees. So when the 2x, like let's say this is x, 2x is equals to 90, so x will be equals to 45 degrees. So right isosceles triangle have the angles 45, 45 and 90. Okay, so next thing is about finding the area. Okay, there is a formula for the area. So area of a triangle is, let's say this is the base. This is the base of the triangle, and this is the height here. So what we do, the formula area of a triangle is, okay, the thing about the height is we draw it from one vertex to the other side, and it should be 90 degrees. The angle should be 90 degrees. Let's say we have a triangle which looks like this. So we have a triangle which looks like this. Let's say we consider this as base. Then what should be the height? Okay. Now in this case, if we want to find the height, we would have to extend this line like this. Imagine this line is being extended. Then from the opposite vertex, we have to draw this 90 degree here. We have to draw. So this is the height here in this case. Okay. So we extend the line and then draw the line that perpendicular outside. Okay. So we have the area is equals to 1/2 times base times the height. All right, so let's say this is just an example. So, okay, like the one that I gave you before, like if this is outside, then we measure this height here. We draw the perpendicular line, we extend this line and draw the perpendicular on it. And then what height we get? That is the height. So this is h, this is 12. And when we dealing with base, you only make like, so this much is the base. Okay, so this is the base, and that is the height. So it will be 1/2 times base times the height. So 1/2 times 20 times 12, that is 120. So the area of this triangle is 120. Okay, so the next topic here is uh, the law of sines. Okay, so like we can like combine it into its complete topic is like law of sines and cosines and its practice questions are like kind of applications. Okay, application, or you can say questions. So that's what we're doing here for this topic. So second one is the law of sines. Law of sines. Law of sines defines the ratio of the side of triangle and their respective sine angle are equivalent to each other. The other name for the law of sines is the rule or sine formula. The law of sine is used to find unknown angle or the side of an oblique triangle. So what is an oblique triangle? Like triangle which is not a right triangle, let's say like this. This is an oblique triangle. This is not a right triangle, so we cannot just use the sine, cos, and tan ratios for this normally, because those ratios are for right triangle, like in normal form. But we can use the law of sines for this. This is an oblique triangle. This is also kind of an oblique triangle, okay? Because they are not right triangles. They're not, none of the side is 90 degrees. So, which is not right angle, okay? The law of sine should work at least two angles and its respective measurement. Okay, so if we want the law of sines to work, what we need at least two angles and their respective side measure at a time. Like we need total, there is four things: two sides and two angles. So if we know three of them, we can find the fourth one. So the law of sines is like, this is the definition for it. Okay, it's a over sine A equals to b over sine B and c over sine C. Okay, A, B, and C are the sides of triangle. Let's say like this. Let's say this is angle A, this is angle B, this is angle C, capital. So the side opposite to C is small c, the side opposite to A is small a. So these are the sides. The small letters are the sides. The sides are A, small a, and the angle are capital letters. Okay, this is side B and the angle is capital B. This is side C and the angle is capital C. So the law is A over sine A equals to B over sine B equals to C over sine C. Okay, yes, here, that's it. So this is the angle A, and this is A, small a, the side. This is the angle B, this is the side B, right? This is the angle C, and this whole side will be C, right? So what we are saying this side length A over sine of angle A, this angle, is equals to B over sine of angle B, right? This is A, this is B. Similarly, it equals to C over, C is small, okay? These are the sides. Sine of angle C, this one is capital C, okay? Like that. So this is the basic formula for the law of sines. Okay, so there is different like forms that we can use using the law of sines. The first one is the same that we just wrote. A over sine A equals to B over sine B equals to C over. And there is one more thing, which is we can also flip them. We can write it sine A over A. We can also have this. Okay, this is and this is. They both work for it. All right, so first one is the same that we have written. The other one is telling us the ratio of A ratio B ratio C, side A, side B, and the side C. Okay? The ratio of these three sides is equals to the ratio of the angle A, sine angle B, and the sine angle C. Okay? And the third formula tells us A over B is equals to sine A over sine B. Okay? And similarly, B over C can be also be sine B over sine C. So these are just some modification, or you can say some simplifications in this formula that we can use depending on what we are trying to find. Okay, so the application of the law of sine is, if we can use it to find the missing angles and missing sides of the triangle. For example, let's say here, okay, in triangle ABC, let's say we have some triangle. Let's draw it. Do not worry about the size and the shape. It can be different. Okay, it's not according to scale. So the angle B is 21. Let's say this angle here is 21. Angle C is 46. Okay, this angle is 46. This is the side length AB. This is the side length AB, or we can also say this is the side AB is also equals to small c. AB is the same as the small c, so which is 9 centimeter. Now we want to use the law of sines to find the angle A, the side length B, and the side length A. So the missing things that we want to find is this B, this angle A, and this side. Okay, can anyone tell me what is the angle A? How much will be the angle A? Can anyone tell? Anyone would like to participate? Anyone wants to answer? No? Okay. So how we find the, if we know the two angles in a triangle, if we know the two angles in a triangle, can we find the third missing angle? Yes, we can find the third missing angle because we know the sum of the angles in a triangle is 180. Sum of the angles in a triangle is 180. Okay. So 180 minus 46 minus 21. All right. So 180 minus 46 minus 21. All right. So that is equals to 113. All right. That is 113. So the angle A is 113. All right. So now the two things are remaining. Now the two things are remaining that we need to solve for. The one is this B and this A, side length B and the side length A. Okay. So so what we need to find? We need to find A. Let's say we start with A. So A over sine angle A should be equals to, we should use the other one that we know. So we know the side C. So I will use C over sine C, because if I want to use this formula, I should know 3 things out of 4. 3 things should be known out of 4. Okay. 3 things out of 4 should be known. All right. Then A over sine A equals to, so A, how much is A? That's what we want to find. We don't know. What is this angle A? That is 130. What is the C? That is 9. C is the side opposite triangle C, right? And then what is the angle C? That is 46. Okay, like this. This is 9, right? And this is A. Okay, like this. And similarly, if we want to find the B, what we should have to use? The B will also be equals to B over the sine 21, because the angle 21 is the B. Angle B is 21. All right. Okay, so now we have this. So let's do it one by one. Let's do one by one. So let's do A over. So let's first start with the A. All right. So A will be equals to, because A over sine A is like sine 113 equals to 9 over sine 46. So we will write it like there. So that will be A is equals to 9 times sine 113 over sine 46. Then you need to use your calculator. To simplify this. So if you will use your calculator in degrees, okay, keep your calculator in the setting of degrees, not in radians. If your calculator is in radians, you will not get the same answer, or you will not get the correct answer. Okay, so the calculator should be in degrees. Okay, so if we will do that, we get 100, oh sorry, 15.11 point this. Okay, this is the side A. Now we have to find the B. Now we have to find the B. All right, so okay, so what's the okay, so for B we will do is, here it is. So okay, so here we have it, B over sine 21, B over sine 21 equals to 9 over 46, because B over sine B will be equals to what we know, things that we know, C over sine C, because we know the sides and the angle. So we put there, and then we cross multiply this sine 21 on the other side here. And again, using the calculator, we get 4.485, right? So that's how we can find, if we are given any two angles and one side, if we are given, like, what are the possibilities that we can use? Two angles and one side, right? Or two sides and the angle that is, like, it's like the angle should be the one that is opposite to them, opposite to any side. All right, the angle, the one angle which is opposite to the any side, right? Or you can say not the angle, not the including angle. Let's say if I am given like this, for example, let's say this is A, this is B, and I'm given this angle here. Okay, now I cannot use the law of sines. Why not? Because the angle and the opposite side should be known. Okay, angle and its opposite side should be given. All right, so if I am given two sides, I should be given something which is opposite to it, the side which is opposite to it. Let's say if I am given this side, the red one, right, and I know this A and B, then I can use it. I can use this side and then I can find this angle and this angle, right? So there is two ways. If any two sines and one side, like the side opposite to the any angle is given, or the two sides are and an angle, okay, and an angle that is opposite to any of the two sides is given, then we can use the law of sines. Is it okay? Is it clear?
Guys, it's clear? If you have some questions, you can turn your microphone, ask directly to
It's
the
clear,
teacher.
teacher.
Okay, perfect.
Okay.
You can continue, teacher.
Okay, so the next one is the cosine rule, or it's also called law of cosines. All right, cosine rule or the law of cosines. Okay, now again we have a triangle A, B, C. Okay, we have triangle A, B, and C. The side opposite to capital angle C is small c. Side opposite to angle A is small a, and the side opposite to angle B is small b. Okay, so what does it says? It says if we want to find this side A, okay, what we want to find A, all right, what we need, if we want to find A, what we need to know, it says A squared equals to B squared, so we should know, okay, what we should know. Okay, we should know B and C and the angle A. If we want to find the side A, then what we should know, the B, C, the sides, and the including angle, right? This angle, like this and this. If we know this, then we can find the A. A squared equals to B squared plus C squared minus 2BC cos angle A, right? So you will not see the A in these again, right? A is on this side. There is no A on this side. There is a capital A, which is the angle, right? Now, if we want to find the side B, what we should do? It's like this: B squared is equals to. Now you will not see the B here again. Okay, there should not be any small b. The side B should not be on this side. It should be here. Okay, and we should know the angle B, capital angle B. And similarly for the side C, it's like this. Now if you have a question, like let's say we want to, instead of finding the side, let's say we want to find the angle. Yeah, instead of finding the side, let's say we want to find the angle A, right, from here. So let's try. So what we should do, first of all, I should try to isolate. So I will move the B and the C on the other side. Okay, A squared minus B squared minus C squared is equals to minus 2BC cos A. Then what I'm doing next is I divide both sides by minus 2BC, minus 2BC. So A squared minus B squared minus C squared divided by is equals to cos A, right? Or what we can do is I can distribute this minus on the top. Yeah. When I distribute this minus on the top, it will become minus A squared plus B squared plus C squared over 2BC equals to cos angle A, right? I can rewrite the negative. I can write it like this: B squared plus C squared minus A squared over 2BC. It is cos A. Okay, then what I need to find A. What I need to do to find A, I need to get rid of this cos function. I need to get rid of this cos function. To get rid of that, we have the inverse function for that. Okay, so we do cos inverse on both sides. This function, you can also find it on the calculator. Okay, you don't have to worry about it. You can find it on the calculator. And the cos inverse will cancel out, giving you A. So if you want to find the angle A, what you need to do, cos inverse B squared plus C squared minus A squared over 2BC. Okay, now let's say I want to find the angle B. Okay, I want to find the angle B. So the change is that should be there, that will be there, is cos inverse. Now it will be like A squared plus C squared minus B squared. You see, when we were finding A, it was minus A squared. Now we are finding B, so it will be minus B squared. And there was no A in the denominator. There was no A here. Now there will be no B there. And similarly, if we want to find the angle C, that will be equals to cos inverse A squared plus B squared minus C squared. The one that is there, it's minus C squared here over 2AB. Now there will be no C in the denominator, right? So I gave you 6 formulas basically: 3 for the 3 sides and 3 for the 3 angles. All right. Okay. So let's move on to some the applications of law of cosines. Okay, so its application. So basically, what's the application of law of sine, law of cosine? The application is nothing else than solving the triangle. Okay, if you're given some sides, if you're given some angle some side, you want to find the remaining angles, remaining sides. So what we do is we use the law of sines and law of cosines, right? Okay, so what we are having here is a triangle A, B, C. This will be A, this will be C. All right. Okay. Okay. Now what's given? Triangle ABC. AB, AB. All right. This side, which is AB, is actually the side C. All right. This side. This is equals to 42. BC, this side A, is equals to 37. All right. And AC, which is this one, is equals to 26. Okay. So what they want us to do? Okay. So now what we need to find? We need to find the angles A, B, and C. We are given the three sides. Now we need to find the three angles, right? So which formula should we use? We need to find A, we need to find B, and we need to find C. So if you remember what the formula that I told you for A is equals to cos inverse B squared plus C squared minus A squared over 2BC. Okay. You can do it this way. You can write it like this, substitute the values, and then can simplify, and then can get to this answer. Okay, that's the same. It's the same thing. That's also perfectly fine to do. But if we know the formula directly that we derived before, if you know the formula directly, right, you can use it directly. It will save time and it's more quick. Okay. So what we do is we put cos inverse. Now B, what is B? Here, look, B is 26 squared. What is C? C is 42 squared minus A. What is A? 37 squared over 2 times 26 times 42. All right. And when you will do it using the calculator, you will get cos inverse and cos inverse, and then you will solve this inner side, this whole thing. All right, you will get 0.4904. Okay, and when your calculator will be in degrees setting, and you will do cos inverse of this, you will get 60.63. Okay, if any of you have the calculators with you, can you check it? Can you try to do it with your calculator and see if you get the same answer? Try the cos inverse function. So like you can see it. Okay. Similarly, we need to find the B and we need to find the C, or actually we need to find B and C too as well, right? So B will be equals to, angle B will be equals to cos inverse A squared plus C squared minus B squared over 2AC. A squared is 37 plus C squared is 42 and B squared is, and the denominator will be AC, that is 2 times 37 times 42, right? So let me do it in my calculator. 37 squared, plus 42 squared. Till then you can also do and tell me the answer. Okay, do it and tell me the answer what we get. Okay, so what I got is 0.79. Is any of you got that? If you did, let me know. Okay, then we will do cos inverse. Then we will do cos inverse 0.079. So I get 37.8. All right. So I got the angle B equals to is equals to 38.1 something. Okay. And similarly, we need to find the C. Similarly, we need to find the side C. Right. Let's find the side C. Okay. So C will be equals to A squared plus B squared minus C squared over 2AC. Okay. When we put that, oh, and there is cos inverse outside. Sorry. Will be cos inverse. Okay, so C equals to cos inverse. Okay, now what is A? 37. What is B? What is C? Over 2 times 37 times 26. Okay, so that will be equals to, so cos inverse. Let's do that, the calculator. And also, if you also do it, tell me what's the answer you get. Okay, I get it approximately 0.146. Any of you got this answer? So that gives us approximately 81.60. Okay, so we got three angles. We got the three angles that we were looking for. So we got this, that's the C. We got B, and we got the A. Okay, is it clear? Okay, all right, so okay, there, these are like the two exercise questions which you can try, which I would recommend you to try. All right, and you can tell me the answer in the comments, okay, below or somewhere. So, and then we can, and then I can also provide you the right answers for them. Okay, so just try these yourself and then let me know if you would have problem in the comments. All right. Okay, so now the next thing is what we are doing is sine. The next topic is sine and cosine functions. Sine and cosine function. Right? What we was doing above was the sine rule and cosine rule. Law of sine, law of cosine. That's different. The sine is a ratio, right? Cos is a ratio. So that's the sine rule, cos rule are the ones that are using. So now these are some functions. These are like the sine function and cos function. So the thing that you're looking on the screen right now is a unit circle. Okay, its length is 1 unit, whatever. It can be 1 meter, 1 millimeter, 1 centimeter, but it should be 1. The length is 1. It's a unit circle, right? When we divide a plane, xy plane, into two, like with the x-axis and the y-axis, it divides it into 4 parts. It's called first quadrant, second quadrant, third quadrant, fourth quadrant, because it divides it into 4 equal parts, right? So let's say I have a triangle, right? This is 0, 0. This is the point 0, 0. Right? And this is the point xy. This is a point xy on the circle. This is a unit circle. This is a unit circle, so its radius is 1. Right? This is a right triangle here. That's a right triangle here. That's a right triangle here. Okay. So, okay, can any one of, okay, what is this height? How much is this height? Or this one? How much is this height? That's the y, right? Because it's from 0 to there. That's the y. That height is the y, right? And the other height, this length is the x, right? X. So that's why the coordinate of this point is xy. Okay, now what we do is I ask you, like, what is the sine ratio? Sine is sine of angle. Let's say the angle is t here. Sine of angle t will be equals to opposite over hypotenuse. Okay. Opposite height, this is y. This height is y, right? From there to there, its length is y. So opposite is y and the hypotenuse is 1, right? That's equals to sine of t. So y will be equals to sine of angle t. Okay. Similarly, here look, this length is x. This much length is x, right? Because it's x units from the center. So this is x. Now, what's the cos ratio? What's the cos ratio tells us? The cos ratio is adjacent over hypotenuse. So adjacent, the one that we have here, is x and hypotenuse is 1. So x is equals to cos of t and y is equals to sine of t, right? So this is basically this point. If we want to define this point on the unit circle, if we want to find this point on the unit circle, it will be sine t cos t. Oh no, sorry, I wrote the opposite. X first, right? Cos t and sine t, right? So x value represents the cos t angle t and the y value is the sine angle t, right? And there's basically, okay, so all right, here it is. So these are all the values, right? That, like, not all the values, but all the values that can be written in terms of whole numbers or in terms of fractions. Okay, what will be this point? What is the y value for this? It is 0 because the height is 0, right? But the x value will be 1. So this is 1 and this is 0. So cos of t and this is sine of t. So cos of 0 will be, this is cos of 0, angle 0, and this is sine of angle 0. So sine of angle 0 is 0 and cos of angle 0 is 1. Similarly, this is the cos of angle 30, sine of angle 30, cos of angle 45, sine angle 45, cos angle 60, sine angle 60, cos 90, sine 90. So these are the whole table. This is the whole unit circle. Okay, these are like some important angles that we have there, and we have the values for them, right? So these are the sine and the cos values for them. And there's a thing you might notice, In first quadrant, all the ratios, all angles like sine, cos, even tan, and all of them, they are positive. You see, no negative value. In this one, you see the first one is negative. What is the first one? The cos, all right? So in the second quadrant, the sine is positive, all right? Only the sine is positive. In third quadrant, you see sine and cos both are negative. Sine and cos both are negative. The tan ratio is so in this, when we divide a negative by a negative, we get positive. So in third quadrant, tan ratio is positive. And in fourth quadrant, the cos ratio is positive. You can also see the sine represents the y. Sine represents the y. So when we are above the x-axis, the y value is positive. So the sine is positive. Okay. The cos represents the y-axis. Oh, sorry, the x value. Cos represents the x values, right? So when you are on the right side, here of the region of the y-axis here, the cos values, the x values are positive. The cos values are positive. You see the cos values are positive in first and fourth, and the sine values are positive in first and second. And in third one, both sine and cos are negative, but the tan is positive. Okay, so there is just some like general trigonometry. That's the last topic for now. So the last topic is general trigonometry. So as I have done something before, like I have mentioned some before, like so triangle, basically it's the ratios of triangle. We're using sine ratio, cosine, tan. All right, these are the, okay, so like sine, cos, tan, right? And we see these like, let us see how these ratios are function evaluated in case of right triangle. Consider the right triangle where the longest side is called the hypotenuse and the opposite sides is opposite and adjacent, right? So that we are like, when we talking about sine, cos, tan, we usually talk about the right angles. Okay, so this is the right triangle that you can see we have already discussed. Yeah, so like that's a sine, tan, cos. Okay, then okay, so there are 6 important trigonometric functions. Okay, 6 important trigonometric functions that are there. So the sine is opposite over hypotenuse. There is tan is opposite over adjacent. Cos is, okay, so like some people to memorize this, they sometimes write it like this. Okay, like this. So the first one is sine. It's like this. Sine equals to opposite over, that's SOHCAHTOA. So co is C for cos, A for adjacent, and H for, okay, and then TOA. So that's for TOA is means tan, T for tan, that's it, adjacent over. So you can like, if you want to remember it in a shortcut, you can write this, remember this, so okay, like that. So these are the 6, basically 6. The 3 3 basic, and the remaining 3 are the reciprocals of these. Okay, like you see, when it was sine, it was opposite over hypotenuse, but the cosecant is related with the sine. That's hypotenuse and opposite. So it's like it was O over H, now it's H over O. Similarly, this is tan and cot. They are related with each other because tan is opposite over adjacent and it is adjacent over opposite. And then cos and secant, they are the reciprocal of each other because this is A over H and this is H over A. Okay, so here's the next thing that we have. This is a table. This is the table for the values of some important angles. Okay, this is the table for the important angles. So the sine of 0 is 0, sine of 30 degrees is 1/2. Okay, I can tell you a quick, like we can see a quick way. So first of all, what you do is you write 0, 1, 2, 3, and 4. All right. Then what you do is you divide it. You divided them by the 2. You divide them by the okay, no, wait. Before we divide, we do the square roots. Before we divide, we will do the square roots. Square root of 2. Okay, so what is the square root of 0? Square root of 0 is basically 0. Square root of 1 is 1. Square root of 2 is square root of 2. Square root of 3 is square root of 3. And square root of 4 is 2. Then we divide this by 2. And 2 over 2 is 1. All right. So in the last one, we get 1. Square root of 3 over 2. Square root of 2 over 2. And this one, we can use this. Square root of 2 over 2. 1/2. And 0 divided by something is 0. Right. Then you just write them in the opposite order. 1, you see, last one goes first one. Square root 3 over 2, square root 3 over 2. Then we have square root 2 over 2, and this will also be square root 2 over 2. Square root 2 over 2, square root 2 over 2. And 1/2, so 1/2. Okay. Then 0, so it's 0. And for the tan, we divide them. For the tan, we divide these two. We divide these with each other. 1 divided by 0 is 0. Square root 3 over, so 1/2 divided by square root 3 over 2. So it will be 1 over square root 3. Square root 2 over 2 divided by square root 2 over 2 is 1. Square root 3 over 2 divided by 1/2 is square root 3. And then when we divide something by 0, it's infinity or undefined. Okay, so this is like a way if you want to remember this table. And then the remaining is like you also just have to flip them. Like the sine cosecant is 1 over sine, right? So 1 over sine means 1 over 0. Look at this value. 1 over 0 is undefined. Okay. Similarly, it's 1/2. So when you will flip it, it will be 2. And square root 2 over 2 is like actually when you will flip it, it will be like 2 over square root 2, that is actually square root 2. So these ones, the remaining 3 are actually the reciprocals of the above ones. Okay, there is some important identities that you can see that is very famous in trigonometry. The first one is Pythagorean identities. It says sine squared plus cos squared is equals to 1. Okay, so now let me explain you how. Because let's say we had the same unit circle, all right? This length is 1. We are in the same unit circle. All right. So let's say this is the x value. This is the x value, that is A. And this is the y value, that is B, right? So the thing is, let's say this is the angle theta, right? What was the coordinates? We know that we call that cos of theta and sine of theta. We just saw that if this length is y and this length is x and this length is y, then this is like this, right? X equals to, we proved it before, x equals to cos of t and y equals to sine of t. We have already shown this before. All right. So there is a famous Pythagorean identity that we know that says x squared plus y squared is equals to r squared. For a, like x squared plus y squared is equals to r squared. Now what is the radius here? It is a unit circle, so radius is 1. So r squared is actually 1. What is x? X is cos squared t. Okay, theta or t, or theta, we can use theta as well. T, theta, a, b, c, doesn't matter. Plus sine square of theta. So this is the first identity that we got. Sine square theta plus cos square theta is equals to 1. Then what we did in the next one, we divided by cos square. We divided the sine square theta plus cos square theta equals to 1 by the cos square theta. Okay, so sine square theta or cos square theta is tan square theta. Plus this will cancel out, plus 1 is equals to 1 over cos square theta will become secant square theta because they are reciprocal. Similarly, for this one, we divided the first one by the sine. All right. And there is some other identities. Sine 2 theta is equals to 2 sine theta cos theta. Cos 2 theta equals to cos square theta minus sine square theta, and tan 2 theta. So these are like the basic identities that we use normally in trigonometry to solve different equations and different trigonometric equations, right? All right. Okay, so that's it for today, I think. If you have any question.
Okay, guys, everything is clear, or do you
It's
have
clear,
any
teacher.
questions? Okay, excellent. Excellent, Sarah. Thank you so much. Have a wonderful day.
Welcome.
To you and to all
You
of
too.
you guys. Thank you to be here and be present for next class. Have a wonderful day. Bye.
Bye, Miss.
Bye, Mitchell, Arturo, Rafaela,
See you.
Johnson, Mela. Thank you. Bye.